And share my screen.
Yeah.
Like I said, it's everyone of my, for example, like friend, is someone who
Good. I should be able to see my screen any second, I hope. Actually, does it? Come on, you can do it. There we go.
So it's in Twitter, Facebook, and the rest of it is like
Good. Right.
Doing it.
So, thank you very much for coming along to .NET Knots. I see this. Good. We do have a code of conduct in place. Let me just stop the YouTube as well, because that's going to get distracting very fast. That one. Oh, isn't that better? Confusing. But really, this boils down to be kind and considerate to others. And if you have any trouble with anybody in the meeting, then by all means send either myself or Connell a message in the chat, and we'll endeavour to put things right for you. But on that note, we can move on a little. We do have some sponsors for tonight. We are in person here at BGSS. Thank you very much to them. And we're also sponsored by Rebel, and they are providing us with soft drinks and pizza. So those of us that are in person get to eat that. Onwards from that, I still do all of the hosting through my my business, PJG Creations, so that's why that logo gets to be there. But also JetBrains are sponsoring us a license to one of their products. If you don't know what JetBrains do, they make developer tools for developers. So things like WebStorm, PHP Storm, ReSharper, IntelliJ, all of those type of things. Yes, yeah, lots. Some of it's free actually now, which is nice. But if you would like to win a 12-month license to any one of those products, then do tweet on the hashtag .NETKnots. And at some point later, we'll pull that out of a hat and donate one of those to you. If you already have it, by all means, still accept, and you can give it away as a Christmas present. Hey, so by all means, do that. In fact, both the speakers and myself are MVPs. You're an MVP, aren't you?
I am a retired MVP.
A retired MVP. Yeah, that's true. It gets harder and harder actually now to be an MVP, at least as far as paperwork is concerned, or digital paperwork. But nonetheless, if you're interested in becoming an MVP, then this is a journey which will be interesting to those that like to speak in public or organise meetups like this, or perhaps open source contributions or blog posts, anything like that, in and around the Microsoft space. So if you're interested in that, by all means, send us a message and we can help you with that journey. Onwards from that tonight, we have John Staveley talking about demystifying gRPC. And we have the awesome Rendell talking about how simple is as simple as possible too. So two awesome speakers and some great topics. And I'd normally have what's coming up next, but actually it's December next. So what is coming up next is Christmas for us folks, celebrating that. So during that festive period, there will be no .NET Knots, or indeed no Knots IoT. But we will be back in the new year, so keep your eye on a little bit on Twitter, but we'll also have a Blue Sky account by then as well. So by all means do that. So with enough of that waffling, I will stop sharing my screen and we will get on to our first speaker, which is John Staveley. So thank you very much. So you can steal that. And then you just need to do the Zoom sharing bit. I can see it, and I think if somebody came, I'd be able to see them. Right. Again, if you've got any questions, actually, then by all means put them in the chat, and between Connell and myself, we will moderate that and ask our speakers as they go. And there will be a break in between John and Rendell for you to be able to ask questions then too. But John does have to leave pretty sharpish after his talk, so during the chat's probably going to be the best plan for that one. Thanks, folks.
Can you hear me out there? Where's the thing that says, where's the thing that unmutes me?
You have a green square around you. Does that mean?
Share. It should be underneath it.
Right.
Yeah, just hovering over that will give you everything you need normally.
Okay.
Yeah, so just make sure, well, I can see the little green thing going up and down. So
Okay.
They say we can.
They support you on the venue, Mike, right?
No, no, it's fine. Yeah, looks good. Yeah. Thanks, Pete. I assume everyone can see my screen and me.
Yeah, see green.
Yeah,
And you?
great. So my name is John Staveley. As Pete said, I'm an MVP. I live in Leeds. My day job, I'm a .NET contractor. I also organise Leeds Sharp, Leeds Data Science, and the AIoT Hub, which is sort of UK-wide IoT network. Personal interests, I do triathlon, canoeing, teach sailing, and a bunch of other stuff. So here I'm here to talk to you today about gRPC. And my mission today is to bring a bit more awareness in the .NET community about gRPC. So it's a well-known technology, but for some reason, I don't understand it's not well used in the .NET world. So I'm going to talk today about who uses it. There's some big name firms there, what it is exactly, what advantages it gives you. Why do you want to use it? And then go through some examples with the Visual Studio and use the basic tooling that gets you set up really quickly. Then look at some of the particular use cases it's great at, like streaming and also using it over the web. So who uses gRPC? So Google created it in 2015. If you've got Dropbox installed, then it's firing a sort of messages, keeping things update using gRPC. Expedia, Spotify, Kubernetes Kube Control use it as sort of the interfacing network that glues everything together. So there's thousands of low latency messages passing between all different cubes. Lyft and Uber use it for real-time positioning, so you can watch your car approach you as it goes around the road network. Cisco, IBM, Docker, Dapper's got it as distributed application. It's got it as the thing that glues all of its components together. Netflix and Salesforce. So Salesforce use it. So if you want to interoperate with Salesforce, then they use gRPC. So it's got good support across all different programming languages. And they said, well, to talk to us, you just got to use gRPC. So what is gRPC? So it's HTTP2 and it's binary formatting. So that gives it some of its performance and speed advantages, and uses something called protocol buffers, or protobuf for short. So that's an interface definition language. It uses TLS rather than SSL, so it's secure by default, encrypted over the network, and it has all the things you'd expect: cross-cutting concerns like authentication and error handling. And great language support: C#, C++, Dart, Go, Java, Kotlin, Node, Objective-C, PHP, Python, Ruby, JavaScript. Everyone's got a package to interoperate with it. So look first at, if you're considering why you'd use gRPC over, say, something like REST, for instance. So what are the things they have both in common? So they're both cross-platform, but gRPC is 7 to 10 times faster than REST. So if you care about performance and speed and low latency, you really need to think about using gRPC. So REST has native browser support, whereas gRPC, you need to use something called gRPC Web to support that. More on that later. REST is very loose contracts. You can add a few things and deduct things off your JSON package, and it sometimes won't complain too much. Whereas gRPC says, I'm expecting a block later. It looks like that. And no variants, please. Thank you. JSON is human readable. However, on the flip side of that, gRPC with the correct tooling becomes quite easy to understand over the wire. If you've got massive payloads, you're uploading images or large documents, that kind of thing, then that's something that gRPC is not great at. because the binary serialization is like zipping a zipped file. You're not going to get any performance advantages over that. So what about gRPC versus GraphQL? So you might be considering that as some way of interoperating. So both released about 2015, 2016, has some advantages over REST. Well, both of them do. They both use an interface definition language. They're both open source and they both publish a single endpoint. But setting them against each other. So gRPC is used over HTTP2. GraphQL doesn't really care. gRPC uses protobuf, and that gives it a smaller packet size and faster serialization. So it's faster to send over the wire. Whereas GraphQL says you're going to use JSON and that's all you're going to use. gRPC can use a single method at a time, whereas GraphQL, you can combine different data, in fact, design the data packet you want over on the fly and makes combining those calls easier. So sometimes that can give you a performance advantage. With gRPC, you've got stronger coupling. So again, it uses a data packet that has a very specific format. Whereas GraphQL is a bit more flexible. So it enables weaker coupling with your endpoints. So GraphQL allows one-way streaming, whereas one of the killer use cases of gRPC is two-way streaming. So you can open up a pipe and it can fire packages to and from over the wire very rapidly. With GraphQL, caching of GET requests doesn't work by default, whereas gRPC caching is quite a good story there. So we're going to go through a demo on how to get started with C#. So look at the NuGet packages you have to install. Just going to see how the tooling helps you here, and then set up your first service project and talk about what you need to put in for the proto file and in startup. Right, so I'm just going to go File, New Project. Thankfully, we have a gRPC template. Helps us out here. Just call it gRPC Service 1. Someone's grinding coffee. So just select the defaults. Crunch, crunch, where? Okay, so we've got a blank project. What do we get by default? Excuse me. So it's added some packages in for us, the grpc.asp.NET Core. So that enables most of the functionality. And then you've got this greet.proto file. Now, the proto file is just a text file. Now, behind the scenes, when I create something in here, it generates some code behind, which links it all together. So here I'm going to use, so the syntax is Proto 3. So if you look on the web, some examples are still using Proto 2. So you just need to be careful using the right version. So you've got a particular C# focus thing here. So you say there's a namespace called gRPC service 1. So the backing file that it's going to create, my backing file for my service, is going to have that namespace. And it's called package greet. Then this service that I'm defining has a greeter class with a single method called say hello, which is a remote procedure call. It takes a single class called hello request and then returns hello reply. Is this big enough for everyone? Yeah. So hello request takes a name variable and hello reply takes a message variable. This is an ordinal, which I'll talk about later. So let me have a look at the service here. Just going to build that. So if we have a look at what it's built behind the scenes. There you go. There is some beautiful code, which fortunately you never have to look at, but it's what glues it all together. So you saw the proto file. So there's the tooling that's generating this code, and that wires it all together. But just make you aware that it exists and it's not, doesn't work by magic. There's actually some transpilation going on behind the scenes. So the final thing is in the program file, we just need to add a service called add gRPC. So it all hangs together and then map the gRPC service.
And if you want to zoom in a little bit.
Okay, yeah,
Yeah.
yeah. So add gRPC, map gRPC service, and that should be enough to get us going. Okay, thank you, AVG. Meanwhile, I'll do a little song and dance.
I stopped that, just like Windows do its thing these days.
Yeah, okay, so localhost 503. So in my proto file, my say hello required a name. Yes, thank you. We knew it'd be all right. Called John. So I'm going to make this request to the HTTP endpoint. For some reason, I need to format this as JSON. I don't know why. I think this is a Postman thing rather than the gRPC thing. Yeah, and so that called the service, and then it replied with the message, which is hello, John. Okay. Yeah, so hello reply, message, and then went into the service. Oh no, that's hideous. There you go, hello reply. So the bit I missed out about that in there is in Postman, it helps you out. So I need to set up a new gRPC call that just take, it knows already that that's the kind of call it's making, which is why it sent it in the right format and I got the right response. Okay. Okay, so a bit more about ordinal. So ordinal defines the place in the file that it needs to sit at. So I can't change that to 2 or 3 and then and then send something in a different ordinal. It's got to be consistent. You can have optional fields. So I can put in optional here. I can put in reserved. So if I need a field and I don't know what it's going to be called yet, I can reserve that field there. And then I can have enums. I can have complex data types like timestamp. I know, but you have to pull that one in from somewhere else, and then reserve fields 4 to 6. And then I can have complex objects, trees of objects, arrays of objects, just as you expect. So a lot of support for all the complicated data structures you usually need. Right, so that was how to get us started. As you see, we got started really quickly. And we sent it a hello world. That's what hello world looks like. You can also use gRPC curl to make requests to it. bit of an aside on protocol buffers. So this is our interface definition language. So this tells gRPC the kind of data packet you're likely to expect. And you have balls, strings, bytes, floats, all the usual stuff. I have to say the docs are very good at this. So if you've got any questions, then go to the docs. And then I can import other complex data types and types I've made from other projects and that kind of thing. And the field numbers, you see, must be unique. So now we're going to do, so we've called it using Postman. Now we're going to make a quick client and call it programmatically. So I'm just going to make this a console project, console app. And okay. So I'm going to add a reference and let the tooling do the magic for me. So I'm going to do a service reference and select gRPC and then browse to the proto file. Okay, so what whizzed past there is it's adding in 3 NuGet packages that enable building of the client. So there's got this link to the original proto file. And this, rather than you watching me code, I'm just going to copy and paste this in here. Add in one additional NuGet package, which is Bogus, that I use for generating some sample data.
Bogus.
Yeah, it's good. Naughty strings. I don't think that's what we needed. This is embarrassing. It's not found it.
It's like still searching.
Yeah,
Live demos.
yeah. Okay. All right, we'll have to do that without that for a sec. Okay, so yeah, gRPC.
Faker instead says. Mark.
Yeah, I could use Faker, absolutely.
That's what it says, in fact.
Yeah, but Bogus works the same way. It just so rather than giving GUIDs for everything, Bogus gives like Joe Bloggs, Harold Shipman, meaningful names. Okay. So almost there. Really doesn't want to see Bogus today. Okay.
Quick question while you're.
Yeah.
With this providing like server-side streaming, do you see this as kind of a replacement for Signal?
If you could repeat the question, so the folks at home.
Is this a replacement for Signal Art? Rendell's shaking his head, so that kind of like sets the field. So I won't go there. Well, I'd say the killer use case of gRPC is the two-way streaming.
Multi-way.
Yeah.
GRPC.
The web bit is not great because not as great because you have to go through a proxy, so you've got less of a performance bonus there. Obviously, I haven't got any statistics over SignalR versus streaming gRPC, so I don't know. I'd have to investigate that one.
Is it permanently connected two-way connection, gRPC, or is it,
Well, once you open up the pipe, it just keeps it
it's a
open.
website? So,
Yes,
Yeah.
like that idea.
okay.
There you go. Bogus is available.
Hmm.
Why did it
Internet.
take so long?
PHP has a fixtures generated in Paris. That's in the video, example, based on fake image and. The photo files, do you define your entire API in one file or so way of like splitting it?
You can reference, yeah, multiple files, different data types and different files. Yeah, you can do all the things you'd expect to. Okay, I think we're motoring. I've changed the port number. That's the thing I usually forget.
Do keep an eye on your own time. given your
Yeah.
train.
I have got my train to get, yeah. Just going to write logger long information.
Great talk, you just gotta stay here overnight.
There you go.
Someone's asking, Ian Power was asking, I'm gonna come off mute and ask. Because I can do that. How many, won't do that, you need to repeat it. How many concurrent gRPC connections can you have? And if you could repeat.
How many concurrent gRPC questions you have? I don't know. The use case that I worked with, we had multiple, lots of IoT devices calling into a central server. I think we had about 30 of them, and there didn't seem to be any problem. But I don't have any more statistics other than that. You can do concurrency.
Oh.
A lot.
Rendell says a lot.
By default, most servers set this limit to 100. According to the internet.
Third party.
Yeah, maybe.
Yeah.
That's the server configuration, but that was a Microsoft answer.
Okay, so the client code that I copied and pasted in here. So we've got a hello request that uses the bogus library to create a realistic full name. And then we've got the client code. So because our client has the proto file, it generates a C# code behind to wire that all together. We use the hello request object that we created earlier, and then we write any reply we got from the server, and then we wait 1 second. So here we can see both the client and server working. One saying hello, and then saying, I'm saying hello to this other person. So there you go. So with very little effort, we've got a service set up that can do gRPC, and then we've got a client that can send messages to it. So let's say we're gonna make our objects just a little bit more complex. So now I've got a name, I've got an enum called hello type, I've got a timestamp, hello date timestamp, and then I'm going to reserve some fields for later use. And then I've got an additional variable here called visitor number, and I define my hello type here. And then I'm going to change the service so it writes a bit more of that out. Just going to build it so it doesn't complain. So we've got red squigglies at the moment, then the backing files get generated, the red squigglies go away. So I've got the method called say hello. I'm incrementing the visitor number each time, and I'm logging that out. So receiving new visitor number from request name with hello type, and then I'm writing my response to the stream. Not stream, the socket. Okay, so these now I'm going to amend the client code. So I just need to remember the port number. So same deal again, we're going to create a hello request, and this time we're going to do so red squigglies because it doesn't have the backing files to make the request, but if we build it, it will get that information from the source project. So we're going to generate a name as a full name and then a hello type, and then pick a random hello type and set today's date. For some reason with dates, it has to be in universal time and it has to use the 2 timestamp thing on the end. Otherwise, you get a runtime error, not a compile time error, which is a bit annoying. Okay, it's still not working. That should work. Really. It still thinks bogus doesn't exist. Okay, so we're making, again, we're using our backing pre-built client code, calling the say hello method on that with our spec hello request, and then we're writing out the response with the visitor number. So same deal again, we're going to start both projects up. Okay. So here it's saying, oh, hello, you were visitor that, and that's the response you're getting back from the service. So I hope you see how you're using the tooling with the default template. It's really easy to get started with this, and you can do everything you can with GraphQL or Web API or something like that. Any questions so far?
You make them stop.
Only if I code it too. Okay. Right. Yeah, covered that. If your function doesn't take a parameter or doesn't send one back, you have to use the empty type. And then you can use a streaming keyword to say either I'm streaming data to you or I'm streaming data back to you. But I'll go through that. And then we can extend an example with authentication. And as I say, use the docs, that they're very extensive. So quick diversion onto cloud. So EC2, the cloud gRPC support is really good. You have to use EC2 and application load balancer with the Azure App Service. You need to set HTTP to 2 only, and then the proxy is on/gRPC only, and enter encryption on, and then it'll work. If you don't have those, then it doesn't work. And both support Unary and streaming, 2-way streaming modes.
Quick question from Ian Powell again.
Yeah.
You said the messages can go either way. How do you specify that a message is going to go to a specific client? But I'm guessing it's peered, so.
Yeah, it's opened the channel, so it knows which channel to send it back on.
Yeah.
The magic makes it happen. You don't have to, as a developer, you don't have to do anything to make that happen.
So you receive a request on a.
Yeah.
Actually, the question response.
Return, yeah.
Is there any way to push from the server without having the request from the phone? Only if they're running the stream.
Yeah.
Left it open.
Yeah.
And then I guess you've got to instantiate that one thing.
It's like HTTP in that regard. Yeah, it's client initiated. So if your client is running a gRPC service, then yeah, anything can call into it.
Is that why I can't,
Has to be exposing an endpoint.
is that why I can't play SignalR then? Because in SignalR you could, on the server side, say every hour I'll tell all my clients this.
It's that all clients thing.
Well, you can, yeah, you can do that, but the client would have to then call into you to say, hello, I'm here. And then you would just stream one message an hour.
Yeah. That's the-
Oh, right, okay, right.
It works the same way as SignalR. It's just that with SignalR, it's got a built-in send to all the so you basically have the whole client operations, one operation per client on the server, and then you have to have some kind of thread which tell all of them so you can get some message out to all of them.
Sorry.
Okay, so here we've got a slightly more complex example. So we've got a proto file, so we're importing a couple of extra types, the empty type, which is basically equivalent of void, and then timestamp type. And then we've got a number of different methods that the service is going to respond to, and some different objects that you're going to pass in. Here we're going to deal with meter requests. So this is similar to the example I worked on, where collecting a load of telemetry data from a load of IoT devices, sending it into a central server, processing it, and sending actions back to the devices. And then you've got this telemetry service. It just takes meter readings. So this is the unary example. So I'm only sending in one meter reading. It takes a meeting request. Here I'm submitting a stream of meter readings. So this is where I've opened a pipe up to the server. So I'm working with an IAsync stream reader of requests. And then apologies to anyone if you can hear some loud drilling. And then I'm writing out in the stream my responses. So in the proto file here, we're using the stream keyword to do that. So here I've got my submit stream method, taking a stream of reading requests and returning a stream of responses. And I've also got an authenticate method. Let's see if we can have F12 onto that. Oh, F12 doesn't work. I'm sad. Right. Okay, I'm going to do the streaming request first. And so here on my client, this is where my meter readings are coming from. So we've ignored the security token authentication piece for a minute. And we're going to look at here. So I'm going to generate a new reading. So that's just bogus again, and then submit the meter reading using my client code, and then write out any response I get. So this is the open a pipe, chuck some data back down it, get some data back, and close the pipe again example. Right, so here's my client, and it's saying I've sent some data up to the main server, and I've received true back and a date. So here my server's saying, oh, I've received this telemetry of temperature, humidity, pressure, and timestamp. So that's using this single method. So the submit reading. So now we're going to use this one here, where we're submitting a stream of data there and getting a stream back. Use stream. True. So again, getting my gRPC client, and then I'm submitting a stream of data, creating a reading, and then writing to that stream. So my pipe is open and I'm writing loads of data down the pipe. Then I'm going, well, okay, I've written 10 examples. Now I'm going to get the stream of data back again. It's configurable how you do this. So call, yeah, okay, my stream's complete. And then whilst there's data coming back in the pipe, I'll then log it out. Put a little artificial delay in there. So there's my service. The client will wake up in a minute. So bang, 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 sent my telemetry up, and then whoosh, 10 responses come down the pipe. So just using that stream keyword on your proto file and the async stream reader, you can send a stream of data to and from your endpoints. And we do it in batches of 10. Any questions on that? Cool.
Kind of similar to what we were saying before, when you're going new reading there, that's kind of doing a get, or is it that's
Okay, yeah, sorry, there's magic in the background, but all it is just creating some random data.
okay. But in a real thing, it's actually monitoring some sensor and say you've got
Yeah.
100 or 1,000.
Yeah, or
clients.
changes or actuators doing something or
Yeah, and they're all configured to do that on the minute, for example. Does that mean when the clock strikes 00, you've got one for each connection doing a get? It's not like it does one get and sends it to all clients. It does 1,000 different get. Because it's like 1,000.
So we have in the situation I work with, we had lots of clients talking to a single server. And the server was receiving telemetry and then making decisions and pushing something back. Hello. Sorry, did I answer your question there?
No, that's exactly the use case we're talking about, but it's like the under the hood thing. When we said the Signal R example, you could write a hub or whatever it was to say, go and get me that reading,
Yeah,
and it would get the reading once, so it would
Yeah.
be measurement once, and then it would send that measurement that I've now got in memory to all the clients. In this implementation here, you've got each client dialed in.
yeah, this is client server, so this isn't server, because even in the Signal R, the server doesn't know about the clients until the client contacts the server, and then it opens the pipe. Well, here, you can have 50 concurrent connections, and then when it pulls in, you can push something back, but it's going to have to be client driven, not server
Can you
driven.
go back to the previous page of code? Yeah, because you were talking about get.
Yeah.
That's what confused me.
I think so. The generate new reading. So in a real case,
Yeah,
you'd have this loop per client going to get the reading to make a measurement. So is there any? There's no way. It doesn't magically go. I know I'm getting this reading for all 1,000 of my clients, so I only need to get it once. So let's say that was a SQL query, and I'm going into the database saying, "Get me this number." Is it going to be
not
that?
in our use case. All the telemetry is going to be different.
You've got a 1,000 meters and 1,000 now.
Yeah,
And they're all getting the same data.
just exactly that. Yeah.
Because they've got 1,000 clients, each calling their own.
No, so that's a client saying get reading.
If you want to do call requests,
Yes.
then use Signal.
Okay. Right. Okay.
My question was.
Yes.
For what you're doing, why not MQTT or IoT or any number of things, but not gRPC?
Because we didn't decide to do it that way.
I don't know if you have a really good reason.
We didn't know.
Fair answer.
It worked.
IoT,
It worked. What are you complaining about? Yeah.
if you've got multiple different, so if you've got your client calls into yourself, and you've got like 5 different methods on the server you called, when the client calls like method 1, method 2, method 3, for those, is that all one connection? Where you open up one socket and start calling different.
I'd have to pick through that hideous code to work out. I mean, I think you only set up one client. So once you've got the client on the so this
Under the covers, your gRPC.
this client here, we've only got one of them, so we can use that to make calls to submit stream or submit a stream async or hello world or whatever we like using the same client. So I presume.
So
Yeah.
gRPC client is a wrapper around HTTP client. HTTP client represents what gRPC actually calls a channel. So you create it, the first time that you call it opens the connection, and then it basically acts like HTTP client and holds it open until you dispose it.
Yeah, and then you can use that to make.
And you can use that to connect to as many different things as you want. You can also create a single channel and attach multiple generated clients to it. If you've got like 3 different services, you can have them all talking over the same single TCP, HTTP connection. Sorry, we wrote a book on this.
Oh.
Why are you giving this talk?
Rather than meeting up about it. I appreciate it.
Okay. I've lost my space. Right, authentication. Okay, so we need authentication like we do with any service. So a quick and dirty way of doing that is we've got this authenticate endpoint, which takes a token request and token response object. So token request is username and password, token response is our token, and when it expires. So in our telemetry service, we're now decorating everything with authentication schemes, which means if we try and call over the endpoints here, it'll go, you need to be authenticated, go away and get a valid token. Except this one down here, which is authenticate, which is under allow anonymous. So it takes that token request and then uses our really secure generate token model async. Yeah, that's not very secure, is it? And then sends back a token, which then sends with requests. So here we just got, is it authenticated? Do I have a token? If not, call the authenticate endpoint. Where I use my stored username and password to send a token request, and I get the token response, and I store the token here, which is then subsequently sent with all of my requests. Is this large enough for everyone to see? Yeah. So here, once we got the security token, it then gets sent as a parameter on here. So that sends a set of metadata headers that go with each request. And so I'm authenticated. So that's at a very basic level how you handle authentication. Is that all clear? Yep. Okay, now this gentleman here asked about web. So we're going to go and I'm going to show you the web example. So I've got this web client here that makes HTTP requests to my server. So here I'm just using this is a live request endpoint, and I've got one variable called name and a message in response. So if you have a look at this, excuse me. Here it just says I'm responding and then sends a message back. Exactly as our hello world. Okay, so this is JavaScript making the same request to my gRPC service, and it will authenticate first, it will receive the token back, and it'll make the service call to is hello request and then say, hello, John. Easy peasy. Except it's not. It's quite involved, and this is where you're having to work a lot harder. What we've seen so far is some examples where the tooling is really doing quite a lot for you. Here is an example where it clearly needs some work still. So what I've managed to dilute it into is this lovely looking PowerShell script. So I can run this script to generate the proxy files in JavaScript that make the calls into my service. So you need to add the node modules. So just go through npm install. So I need this these three gRPC libraries. So Google Protobuf, as you'd expect, gRPC, RPC web. So they in the PowerShell script need to be loaded into the path. That's just the path for the terminal that's running the PowerShell script. That's not a permanent change, but for some reason it needs to be in that path. Then I'm removing my old files. Then I'm generating my new files using the protobuf command line language that says input style, output style, and a namespace, and then where to store the information. Then I move the files I've generated to a file location that can actually be used. And then I do Webpack on those, and that creates all the beautiful looking code that I've showed you in C# that actually makes the proxy calls to the proxy. So in the service, you then also need to do something additional. Yeah, so you need to do app use gRPC web and then enable gRPC web. Because when you're communicating to gRPC with JavaScript, you're actually communicating with a proxy into that. So that's what that's setting up. So the service goes, there's another layer here that you need to talk to. I think it's because JavaScript doesn't talk protobuf that well. And you need to set cause and just, I've allowed all, but you need to lock it down to your specific application. Give me a demo application. So in the client, excuse me. As we saw, we just got an input box where I enter my name and then a button to send it and then a div to display any results. So this is my very complicated calling code, which does pretty much the same as the other clients have showed you. So using the backing code that's generated, I set up a client to it, go through the authentication process, grab the token, then make a call to is a live request, which I'm pulling from the generated file and then writing out the response. So with the tooling you've seen so far, the tooling is doing a lot for you. With the JavaScript, you have this to play with, and it obviously doesn't look as nice, but this code's on my GitHub. If you want to steal it, please do.
You've got 20 minutes to play.
Yes, and I'm almost finished. And
Not
yeah.
get rid of doing this.
Yeah. So we need to install on the service gRPC web. So that's the proxy. So the service needs to understand, can set up a proxy the JavaScript can talk to. On the client, we installed those 3 NPM packages. And then we needed a beautiful PowerShell script to generate the backing files. And then we had a send.js that just put it all together on the front end. So in summary, if you care about speed, if you care about low latency, then gRPC is something you should definitely be looking at. It's well supported across all the languages I can think of. It doesn't seem to be very popular in the .NET world, so that's part of my talk is to try and change that. Particular things it's good at is for streaming to and from and polyglot services. So if you've got Python talking to Go, talking to .NET, then it's a way of gluing it all together because the language support's great. So we did an example where JavaScript talked to it via a proxy, and the tooling is really great in Visual Studio and Postman. And so Stack Overflow did a really good blog entry, which is about 15 pages long, on when to use gRPC versus GraphQL, because a lot of people will just reach for GraphQL as their interoperability solution. But that's a really, really in-depth article. There's a good Pluralsight library there. As I said, the docs on gRPC are great. Covers all the protobuf stuff really well, with some good examples. And the source code from the second example I showed is on my GitHub, and these slides are also on SlideShare, and I'll share them to the event afterwards. Okay. That's my presentation.
No more questions in the chat.
Okay.
So if you need to get a train.
Right. Okay. We'll swap over.
Yeah. And we can either
I can either swap over and you go immediately, but the pizza is here. So if you wanted to get some little bit of pizza and then do talk,
Grab a little bit of pizza while I set up.
how's that?
Am I stopping sharing?
Yes. Okay, folks. So we're just going to have a little bite to eat for a second while Rendell is setting up. And then even though it was telling me to go wrong at that point on the screen itself, and so I managed to not go wrong. Either way, we will be back with you in just a second. So see you shortly.
Hurrah. There we go.
Up to speak.
No, it's,
Same apology to you. Not usually.
oh, it's fine. It's nice to get into the house and feed people and stuff.
Yes.
I'm not even a little bit hungry. This is the problem, because I had
These
fairly long box.
I would be hungry after that.
You like this, you want those. That's a very weird, but I guess both. You've got both. Yeah.
That's strange.
Fridge also does pigeon impressions every now and then. Instead of the same, no one's doing anything at all. Yeah. It's so much easier than it takes not just for everything. Right, great to see you all. You take care. Thank you.
Right. We will continue. Yes, no, it's- Is there a standard way of publishing your .proto file? With Google, but
Yes, but also no. So not in the same way as there was with SOAP, where the WSDL file was being served by the SOAP server. But you can put your .proto file into the root and turn on static files, and you can serve it from there. But what most companies do is they have a repository where people publish their proto files. What you don't do is generate a client yourself and then publish it as a NuGet package, because if you do that, I come to your house.
gRPC, we know what it is.
Exactly, yeah. Also, the G, nobody knows what it does stand for, but it definitely doesn't stand for Google.
Oh, isn't that it?
Yes, no.
Never been on the case.
They not stand for Google just because they said so. Yes.
Hmm.
Yeah, so each distinct version of gRPC, it stood for something else, like glorious or gigantic or whatever. So
The Go and Golang also not stand for Google.
yeah, that is the single stupidest name
Golang.
anybody has ever given a programming
I
language.
know Rust is up there, just because if you're trying to Google it.
Yeah, good one.
The thing is, though, if you search like Rust string, then you get the dump page for the string type in Rust. If you type Go string, a lot of search engines will just ignore the Go together because it's only got 2 characters, and they ignore anything with less than 3 characters. Yes. And Rust does get all the cool, you've got like Oxide and various other things.
Yeah.
Right.
Okay.
Well, we'll get going with Rendell. So thank you very much, Rendell. Thanks to John Staveley for his talk. He's gone to catch a train. So
Yes.
yeah, but yes,
Back if you missed it.
that's right. Yeah. So yeah, thanks, Wix.
Hello. I hope everyone can hear me. I've got a green thing and no mute thing. So yes, I've brought you all here. I'm Rendell. Just no other name anymore because reasons. I'm on Blue Sky at rendell.dev. Don't try and reach out to me on Twitter unless you want to argue with me, in which case Twitter is fine, because I'm not there anymore. And yeah, I'll kind of explain where the talk came from as I'm going. My video.
So you're not on. You're sharing your screen.
I'm sharing my screen. Oh, but I don't have my video on. Okay.
See your face.
Uh, right, hang on. I'll do it. There it is. Yay! There we go. Oh God, I got. Hello. So yes, I will explain why I'm doing this talk and why I've been trolling it around the place and trying to get people to let me speak about it. But it starts in getting PowerPoint as the, never mind. Hello. Right, there we go. Right, so yes, I've been doing this, I mean, not this specifically, but programming professionally since 1990 when I was 17 years old. And it was a simpler time. This is the kind of application we used to build. This is a WISE terminal, and it had, actually, I think this is a fairly flashy one that had 120 columns, but the standard ones, the ones that most people had 80 columns. And we just wrote applications on this using like C and curses and Infomix 4GL. These are the manuals for Infomix 4GL because this was 1990 and See, what I want to say is there was no internet. Obviously, there was internet. Don't comment on anything saying, but there was no web, there was no MSDN. Actually, there was MSDN, but it came in a huge folder full of CDs. And then every month they'd send you a few new CDs to replace some of the existing. It was just hideous. But yeah, so we had ring binders, which told us how to write Infomix 4GL applications, and people would go and they would get the ring binder and they would find the chapter that they needed, and then they would remove it and put the binder back, which did not work. So you'd have to order new ones every now and then. But yes, and we would build applications. So this is the 1990 Infomix 4GL equivalent of HTML. This is how you designed a screen. You had 80 columns and 20 rows, and you just typed in what you wanted to appear on the screen, and open square bracket and close square bracket, and then you give them field numbers, and then you relate the field numbers to table columns, in this case in the customer and address tables, and then we could run this code here, which displayed that customer form that we designed there, and then put it into a mode called query by example. So this construct by name QCust, that builds a query with where clauses or like clauses or matches, I think it was at the time. And then down at the bottom there, we just say select star from customer where close double quotes, comma, SQL injection attack clipped. And this was, but, and declare QC cursor throw QST, which is a typo. But yes, this was essentially it. And we would build entire applications that could quite happily run a customer's business for them, and they were happy, and it worked, and it was very, very simple. And so earlier this year, I was watching the Olympics, and my favorite thing from the whole of the Paris 2024 Olympics was this dude. This was the dude from Turkey who turned up to do the pistol shooting competition, and he just turned up and he picked up the gun and he went kind of, and then he shot and he got a silver medal. And it's impressive when you see him next to all the other competitors in this this event who just had so much crap hanging off their faces and everything else. And yeah, I mean, I don't know what any of that is. I think possibly some kind of Borg implant or something. But yeah, and then this guy turns up and he was very, very good at shooting a gun at the right point. And yeah, simplicity. Just do things well instead of overcomplicating anything. And so that's the theme of the talk. These are opinions. There are no objective facts in the talk. This is just what I think. If you disagree, that's completely okay. You're wrong, though. And yeah. So, KISS. Because I love KISS, and you've got to have a KISS slide. But no, KISS, keep it simple, stupid. And it's very, very sort of easy to say that, but what are we talking about when we say keep it simple? We're talking about everything. We're talking about the design and the architecture of your application or your system or your solution. We're talking about building APIs. We're talking about the front end. We're talking about the infrastructure that it's all running on. We're talking about external services that you might be consuming or interacting with. And we're talking about the processes that you use as an organization to try and corral 6 angry developers into a unified team working towards goals. So I'm going to go through each of these one by one. We're going to start with design and architecture. And so when we were building Infomix 4GL applications, generally you had an office and it was full of terminals that were connected to like a Tandem 286 with 8 megabytes of memory. And yeah, it was a time-sharing operating system, and so you could have multiple people logged in at the same time, and they would run the application, and it would connect to the database, and That was how everything worked. And so in that sense, it was kind of a monolith. We didn't build microservices. We weren't mainframe programmers. Mainframes have been doing microservices all along, but no, we had monoliths. And when the next wave came along and we started building client server applications with things like Novell NetWare and SQL Base and early versions of SQL Server, you had a rich client application running on all the desktop machines, but they were all talking to a single database. And then somebody went, oh, no, we shouldn't let them talk directly to the database. They should go through like a service-oriented architecture with SOAP and WCF and all this sort of thing. And so then we got these monoliths starting to appear, these single applications with hundreds and hundreds of endpoints and chaos, and it was very, very difficult to maintain and support them. And so somebody came along and went, oh, what about microservices? I believe it was Uber. And yeah, no, the convenience and cheapness of Uber has not yet compensated for them unleashing microservices upon the world. And so we've tried to do microservices. People try to build microservices, and what the vast majority of them ended up doing was building a distributed monolith. And so they would just arbitrarily yank bits out of a monolith and put them into a microservice and then go, yay, we're doing microservices. And no, they weren't, because none of these microservices were any good without all the other microservices, and that's not how microservices work. So yes, it just isn't. And so instead of building distributed monoliths, now apparently all of us people who have been trying to do microservices have got to stop doing microservices because we're not clever enough to do that. And now we have to do modular monoliths. And a modular monolith is, I want to make sure I get this absolutely right. It is a single process, singly deployed solution, but with clearly defined separations of concerns. So it's clean, well-structured code is what it is. It's what you should have been writing all along. It's what you should have been doing with WCF and with ASP.NET web applications and web forms and everything. It's just... And something popped up on this the other day, actually, on LinkedIn. Somebody posted on LinkedIn complaining that all the data access services were put in a data access folder, and all the controllers are in a controllers folder, and all the views are in a views folder. And it's kind of like, instead of that, right, why don't we put everything related to orders underneath an orders folder, and then you can have like data access and controllers and everything. But ASP.NET MVC actually kind of did this with areas for a while, but it was very weird and very MVC-ish. But yeah, basically organize the code, and you can have a different team doing the orders pages and another team doing the stock control pages and another team doing the catalog pages, and just keep them away from each other, keep them into separate projects and all this sort of thing. And that is just as good as doing a modular monolith. That it basically is doing a modular monolith. And if you do that right, and then you go, oh, it would actually be good though if we made this message driven, or we made it independently scalable, then you can kind of go, let's take that one thing out and we'll put it in its own process running somewhere in a container. But what it comes down to at the end of the day is just build the application, keep the code clean, refactor when you need to, and you will find that you are building something that delivers value and that actually lets people use it and do useful things with it. And we also, I had fun with the transitions on this slide deck. And then, yeah, it's fun doing this talk when somebody's just finished a talk on one of these. So yes, but no, this I put in because the first time I did the talk, somebody went, what about CQRS and event sourcing? And it's kind of like, yes. So DDD I went to a DDD conference in Berlin a couple of weeks ago. As far as I can tell, DDD is another way of saying write clean code and manage your separation of concerns. And then CQRS, that kind of makes sense, but that's basically so you have things that change your data and things that read your data and don't make them the same thing or something, which seems fairly self-evident. Event sourcing and event driven, again, perfectly valid things. Event sourcing, so you put commands and they go into a store like Event Store or something like that, and you can replay all of them to make the thing happen again, which you can also do by logging every single JSON message you ever received over the API, time-stamped into blob storage, and then just fire them all back through as well. That is also event sourcing. Yes, it is. Shut up. So yes, just build it, keep the code clean, refactor at will, and don't worry about whether you're doing a modular monolith or microservices or CQRS or event sourcing or whatever. You can worry about that later. You can look back at it and go, we've done CQRS. We didn't notice at the time, but we have. So yeah. Okay, APIs. So like I said, first kind of 10 years of my career, I think, we were all running together on the same machine and the database was a CISAM file somewhere. Or we had a single database, and so the API was literally the database and SQL and maybe the occasional stored procedure. So it was only in the 2000s when we started talking about service-oriented architectures that we started building what we now call APIs. And the first way we did this was with SOAP, which obviously in .NET we did using WCF, which is evil, and nobody should ever use it for anything ever. But no, and SOAP, I just want to be completely clear at this point that the S in SOAP stands for simple. And this is a SOAP message. The bits in black are the data. Everything else is the cruft that describes the data in some way, mainly to do with namespaces. Thank you, XML. And we shipped stuff based on this for 10 years or whatever. And it kind of worked. And, you know, the Java people love it. They're still doing it. JXB and generating clients and servers and all sorts of stuff. So yes, if you need to talk to Java people, get a new job. And then Douglas Crockford came along and went, I haven't invented JSON, I've discovered it. Because JSON is like, it's just the object. It's like a literal object from JavaScript. And he went, oh, you could send that over the wire, and then you could just use eval to turn it back into an object at the other end. And the internet went, yes, Douglas, you could do that. Here's some JavaScript for you to run on your servers. So we don't do that. We use JSON.parse and JSON.stringify. But yeah, this is perfectly nice, I suppose. I mean, nothing wrong with JSON. Then I'm going to rant for a minute. This whole thing's a rant, but it gets worse at this point. Roy Fielding has me blocked on Twitter. So Roy Fielding wrote his PhD thesis on representational state transfer. And he wasn't inventing anything. He was describing the way the internet works. And this idea that you have documents, and within the documents you have links, and the links are normally wrapped around text that describes what the link is, and all this sort of thing. And so what the REST PhD, the paper and thesis does is it describes and formalizes that way of working. And it works perfectly well when you've got a web browser and web pages, because the person who is navigating that is a human, and a human can read the text on the links and hover over them and make intelligent decisions. And for some reason, everyone went, this is the way we should build APIs. And so you end up going back to something that actually looks like this, where 2 of the lines are the data and 16 more lines of JSON, each about 200 characters long, are just showing you things you might want to do with that object that we just sent you as data. You probably don't, but if we include the link, and it's, yeah. And it just makes things incredibly complicated, to the point where we now say, if it's JSON over HTTP, it's a REST API, and whether it actually is or what level of restfulness it's on is just, no, we're not doing that anymore. This really upset the hardcore REST people, and they went off and they came back with Hate OAS, which stands for Hypertext as the Engine of Applications State. And if that's the best you can do at coming up with acronyms, then you don't deserve to get to contribute to the world of computer science. Go away. What we actually have that works and that everybody uses, and we kind of like it, is OpenAPI. I mean, it's completely broken, but it works quite well. If you're a .NET developer, God help me, you can just turn it on in your application, and it will generate the specification for the application that you've already written, instead of you writing the specification first and then creating the application to match it and using various tools to validate that the application you have written matches the OpenAPI spec. We write the application and then go, there's the OpenAPI spec. So if we write the application wrong, the spec is wrong too, which is brilliant. But this is the best solution we have at the moment. If they ever release version 4, it will fix a couple of serious problems with OpenAPI. But yes, there's also gRPC, which I'm a very big fan of. We just saw John talking about gRPC. And it's great. You have proto files, which are like the OpenAPI spec, except you can generate clients and servers and everything from them. It's great for polyglot interactions. It's great for messaging between servers and services within like a web farm or a cloud infrastructure or a Kubernetes cluster. It's really, really good for mobile. And just to add to what John was saying, the 2 advantages of gRPC and protobuf in terms of performance, there's the wire format is very compact, but also the encoding, decoding, or the serialization, deserialization is insanely optimized. And so you're actually saving CPU time, battery on a mobile client, and CPU time generally on a server, which means you can handle more clients all connected at the same time. So yes, if you're building APIs, then I reckon OpenAPI, write the spec, handwrite the spec, and then write the code to match it, or gRPC are both fine. I'm not even mentioning GraphQL in this talk because I hate it with a passion. Okay, let's talk about front end. Let's talk about spas, because spa is a lovely word. This is a spa. This is where I go when I've had too much of the world and I just want to get wet and float and have somebody just try and rub all the knots out of my back. But this is not what we mean by spa in the front end world. No, we mean single page applications. And it's possible that there was some point in recent history when the single page application was a good idea. I think it was around Knockout.js. The thing that's hilarious is Knockout, everyone went, oh no, Microsoft person and no, MVVM and whatever else. And they went off and they invented all these other things. And now they finally said, well, you've come up with millions of different ways of notifying of changes in objects and whatever. And so the Signals API is being added to browsers, and that's Knockout.js. It's hilarious. But no, we couldn't use Knockout.js. We couldn't just use simple data binding. No, we had to go, and by we, I mean Facebook and Google, some people at Google, and just some random dude. Where does Evan New even work? Anyway, but no, we had to go and create these things. And so now when you want to create a website, you go React New or create React app or Vite something or whatever the Angular NG, isn't it? The Angular command line tool. And generate acres and acres of JavaScript. And I did this as a demo. I'm not going to do it again now because it went spectacularly wrong last time, but for the exact reason why I wanted it to go wrong, to kind of make my point. It all went wrong when I ran this. I ran this on a brand new, created from the command line tool, Angular application. And I crashed a PowerShell window and it just would not stop. And you end up, this is, was this Angular? No, this is React, this one. So this is a simple, like, hello world React application. You create it using the command line tool, and then you do npm install, and it adds 604 packages, of which it audits 605, which takes 30 seconds. But it had to download all of those, and it was it wasn't very good conference Wi-Fi because the conference hadn't actually started properly and stuff. And so no, it's a complete and total mess. And then you look at the node modules folder that was created by that previous thing. It's 140 megabytes of files taking up nearly 190 megabytes of space on the disk. All right, and I know that we now have like micro SD cards that can hold 4 terabytes, and you know you can lose like the sum total of human knowledge through the pipe in the washing machine if you leave one in your pocket. But this is insane. This is madness to need to download. For reference, okay, for comparison, back in like around 1990, I think it was 93 or something, id Software released Quake. And Quake was done as shareware, and Quake was the first game that actually had proper 3D. You could look up and down and left and right, and it used floating point maths and polygons, all this sort of stuff. And all the music by Trent Reznor of Nine Inch Nails, and all the levels, and all the textures, and the gameplay, and the engine, and everything else, you can download one huge zip file, 8.54 megabytes. So like 1/16 of the size of the React empty application that doesn't even do anything yet. And honestly, smaller than the download size for most Angular or React or Vue applications before they can actually do anything useful. This is what we've created. This is the world that we have created, where we are focused on the developer experience at the expense of everything else, including the customer experience, the cost to your business, the environment, the suitability of JavaScript for anything except making buttons change color when you mouse over them. But no, we've done this. And then it got to a point where people were going, well, React's really good because Kool-Aid and brain damage, or I don't know. And Angular's really good and Vue's really good, but I've got some problems because people like go to my website and I want them to buy things, but it takes like half a minute for it to download all the JavaScript, and then it has to pass it, and then it has to run it, and then it has to hit all the API endpoints so it can go and get the pictures of the things that I'm selling. And they've got bored because people have an attention span of roughly 0.2 of a second. And also, you've got all your things that you're selling on your website, except Google comes along and looks at your website and it's empty because it's just an HTML index page with some JavaScript, and Google doesn't run the JavaScript because Google is not in the business of running JavaScript. And so, and this was the point where I thought, these are surely the end times and we are circling the drain of civilization and we deserve it. Angular and Vue and React invented server-side rendering. So This works only if your backend is written in Node.js, which is a whole other level of sin. So don't do that either. But yes, it was kind of like, we can run the application, we can run the React application inside the Node.js process and do all the API calls and everything else. And then we'll render static HTML, and then we'll download that. And then we'll download the React runtime or the Angular runtime, and then we'll hit the API endpoints again and pull that data out again. And then we'll rehydrate everything in the browser just so it can do stuff. And there's a way of doing this. It's called ASP.NET Core MVC, or Razor Pages, or Blazor with server-side rendering, if you like the Blazor syntax, or PHP, right? Or Jekyll and just generate a static site. There are so many ways of doing server-side rendering. Everyone kind of goes, oh, it's got a thing that runs in the web browser. We have to use and insert whatever you want. And somebody goes, oh, we should use React. I haven't got that on my CV yet, because it's like you're collecting things. And then as soon as somebody has mentioned React, somebody else will go, well, if we're using React, we should really use Redux for our state management. No, just don't even. It's horrible. If you want to build a website, I'm going to show you something actually while we're talking about this. I told you it was ranty. Hope everyone's having fun. I am. Okay. Oh, for God's sake. Chrome. And I'm going to move it over to here so that you guys can see it too. And we're going to go to okay, this is FretBadger. This is a site I made to help me learn my bass fretboard and music theory. And I can go to here and I can go to the standard. I can click it with the right thing, and it shows me my fretboard. And then I can say I want to see the arpeggios, and I want a D flat major 7th arpeggio. And it will give me that one, and then I can click on any of the ones that say D flat, and it shows me the fingering for that particular arpeggio. And that entire thing, that site, is just ASP.NET Core MVC, and I think a couple of dozen lines of JavaScript that do that bit where when you click on something. And yeah, that's it. It's cached through Cloudflare, so all the pages load incredibly quickly because they're all static, and so they're all just cached in Cloudflare. And I can just, let me just click another couple of things. Oh, I can also add other things in there as well. So if I want like a minor down there, I can click that one, and it adds it into. There we go. It adds it in there like that, and so I can build up a page with lots of these things on there. So yes, not only is that just an ASP.NET Core MVC application in .NET 8 and very, very efficient. Here's how efficient it is. That's running on a Raspberry Pi in my house, which I can't find. I know it's there because the site starts doing served from cache things. But it responds to ping, and K0 is still running, but I'm not sure where it actually is in the house. So yeah, fun. Right. So that's how simple. I've lost my presenter view. There it is. Okay, so I very nearly went down a rabbit hole of going, well, it would be good if when I add a new fretboard in, it doesn't lose where it is. It doesn't kind of like scroll. That's the only problem, is it reloads the entire page just to add on one fretboard. And that could be a little bit more efficient. And so God help me, I started looking at doing it as a Blazor application with server-side rendering, but also then it becomes Blazor WASM, so it can become interactive in the browser. And then I saw this other thing that people were making all kinds of fuss about. HTMX. So HTMX is a tiny, tiny little runtime. It's like 14K, I think. And it just lets you put attributes on HTML that say when they click this, go to the server and get a fragment of HTML and then put it there. And that's basically it. And how much more than that do you actually need a lot of the time? A round trip to the server, and it's going to send you back just the new bit of HTML, and you can either replace or add to the DOM. And yeah, it works. And so what was going to be a huge project to rewrite this thing and then try and compress it down so that the WASM was less than a megabyte has become add a reference to HTMX and add some attributes on links and things. And the great thing is if HTMX isn't there, they don't do anything. And so Google just follows the links as usual and all that sort of stuff. Okay, so yes, where are we so far? We're building, we're not building a modular monolith, we're building a monolith with clean code and with proper separation of concerns. We're building APIs using either OpenAPI or gRPC, and we're building front ends using server-side rendering with ASP.NET Core MVC or Razor Pages and HTMX to just put a bit of polish on the server round trips more than anything else. So, where are we going to run this? Now, full disclosure, the FretBadger code is in a Docker container and it is running in Kubernetes. Okay. I would apologize for that, but the fact is, it's very, very easy. It's using K3s for a start, which isn't actually Kubernetes. It's like a cut down version of Kubernetes. But the Cloudflare tunnel that it's using to pull the actual site from my Raspberry Pi, wherever the hell it is, the easiest way to deploy the Cloudflare tunnel is as a Kubernetes container. The application runs very nicely as a Kubernetes container. And the other application that I wrote that receives a webhook when I push a new version of the image to the GitHub container registry, automatically updates it to the new version. And so that's why it doesn't really matter where the Raspberry Pi is, because I don't need to be able to do anything. If I want to release a new version of the application, I just push it to GitHub and it builds it and publishes it, and then it automatically gets upgraded. It's very, very cool. So that there is that, but that said, you probably don't need Kubernetes. Most organizations don't need Kubernetes. It's really, really complicated. Kubernetes is insane. And you might go, yes, but we use AKS or EKS or GKS or whatever. So we don't actually have to administer our own Kubernetes service, which is true. But let's take AKS on Azure as an example. You don't need to do it. You just spin it up with whatever the current version of Kubernetes is. 1.18, let's say. It was a while ago, but let's say 1.18 because I think I actually went through this. And then they release 1.19, and then they release 1.20, and then they release 1.21, and you get an email from Azure saying, we don't support 1.18 anymore, we only support the current version and the previous 2 versions, so you need to upgrade your cluster. And then you're going, well, do I upgrade it to 1.19 because that's only a single thing, or do I just bite the bullet and go straight the way through? They've deprecated that API, so these things I was using don't work anymore. They've added this new API and changed that one, so those things don't work anymore. Linkerd doesn't work with the new version yet, or Istio doesn't work with the new version yet. So yeah, it's still really, really complicated. And some people push back against the idea of Kubernetes. And there was the second wave of infrastructure, which was serverless. And God, if only this was what serverless actually meant. Like, let's just turn off all the servers and go back to living a pastoral existence and singing each other songs and growing fruit. I'm so tired. So Azure functions, AWS Lambda, and then the Kubernetes people went, oh, serverless looks really good. Let's do serverless on Kubernetes with Knative and OpenFaaS and whatever else. And serverless is just, it's a fantastic marketing tool where they go, don't worry about infrastructure, just send us a function and we'll run it. But you have to write the functions specifically for our cloud to interface with our cloud's way of doing functions. And if you ever wanted to rewrite any of this stuff, it would be an absolute shit show. Also, no gRPC or OpenAPI go away. So yeah, there's that. Somewhere in amongst all of this stuff, though, there is actually one good idea, which is containers. Containers are brilliant. Containers, it's the old Docker thing of, hey, it works on my machine, ship my machine. And, you know, I can have a container, it's got all the dependencies installed. I can run my automated tests on my machine against that container. And if that works, I can probably just throw it at the cloud and it will happily work. So yes, like I'm running K3S on my little Raspberry Pi there, and it does, it just works. So containers, definitely use containers. Containers are simple, much simpler than trying to configure Linux machines so that they've all got the right stuff installed with Chef or Windows machines, God help you. But find the simplest way you can possibly run containers. Throw some Raspberry Pis and Cloudflare tunnels at it. Honestly, you'd be surprised. I think I could run quite a reasonable sized business on Raspberry Pis and Cloudflare tunnels. But yes, so Azure has Azure Container Apps now is the latest thing, and it's got sort of overlap with App Service and Azure Functions. But essentially, you just go, here's an image, run it, and it goes, yeah, right then. And it just does, and it will do the Dapper stuff, it will do the sidecar stuff, it does all the open telemetry stuff, it does all these brilliant things. And Amazon have their version of it, and Google have their version. Cloudflare will be running containers at the edge by the end of next year. That hasn't been announced, that's a bet. But they're very close to doing it. They've already got S3 compatible storage and God knows what else. So yes, just stick your application in a container and throw it at something that runs containers, and you're done. Don't worry about Kubernetes and everything. You'll know if you need Kubernetes. You'll actually run into a problem where you go, oh, you know what would fix this is Kubernetes. That is the right way round to do this stuff. Okay, not, oh, we should use Kubernetes. Now, how does it work? What do we need it for? What's a service mesh? Whatever else. No, wrong way round. External services. I've been working on Azure a lot lately. And so when I say external services, I'm talking about things like data storage, messaging systems, all this kind of stuff. And if you want to use a SQL database or a document database or a graph database or table storage or anything in Azure at the moment, they generally recommend Azure Cosmos DB, which is all of those things. So you have Azure Cosmos DB for SQL, which is Postgres. You have Azure Cosmos DB for MongoDB, which is the document database, but with an API adapter. Gremlin, I think, is the graph database thing. There's the JavaScript, it does key value, it does column family, it does documents, it does graphs, it does the whole thing. And I see so many people just going, oh, we're running in Azure, we should everything in Cosmos DB, and then they wonder why they're running £45,000 a month on a service that's just in UAT. And the answer turns out to be, well, you keep sending 1 megabyte XML documents to this external service, and then they send you 4 megabytes of XML in response. And you, because of auditing, because of financial regulations, you have to keep both the request and the response, and you decided to put them in fields on the Cosmos DB document database instead of putting them in blob storage and storing a reference in there. But yes, this is the thing. Azure Cosmos DB is not simple. It is not. It is very, very, very complicated. And if you decide you're going to use it, you are putting yourself up for an awful lot of complication and figuring out partitions, physical partitions, logical partitions, getting Microsoft consultants in so that they can explain the difference to you and give you notional ideas of how you might be able to optimize it and everything else. And, you know, that thing that we were using right back at the start with Infomix 4GL, a SQL database, just a relational database. And it doesn't have to be a complicated relational database. It can just be MySQL. It can just be SQLite. There is a surprising number of things on the internet that are running multi-user, lots of people all talking to the service at the same time, that are somehow under the covers using SQLite. Okay, they can do it. You could probably do it as well. But even if you can't, then Postgres or MySQL or whatever, just start there. Actually, no, don't start there, because there is an even simpler way to store data, which is called the text file. And you would actually be very surprised if you just explore it a little bit. The data storage and search and indexing and retrieval and everything that is possible with a well-designed directory structure and JSON files, text files, binary formatted. You can use protobuf and save them as binary. You can do all sorts of things. You can get an awful long way with text files just stored somewhere on your disk, or on an attached disk on a cloud server, or in Azure Blob Storage. And you can use directories as ways of indexing into them, so you put the user's name and ID and all this sort of stuff. So this is my rule for storage for external services is, again, I'm going to use Azure as an example. So can I do it with blob storage and table storage? If I can't do it with blob storage and table storage, can I do it with Postgres? And if I can't do it with Postgres, then what the hell am I doing? But also maybe at that point Cosmos, but still trying to keep that down as small as possible. So start from that ridiculously simple point and scale up as you need to. And then we get to talk about how we actually all get together in big buildings, or preferably over teams, and try and build these things all together. Back in 1990, we used a thing called SSADM. There was SSADM 3.0 and there was SSADM 4.0. Other people used something called Prince 2, but these were insanely detailed and complicated ways of specifying software and everything else. And we now refer to this as the waterfall model of development. Waterfall because you plan the entire project out using your uncanny God-given powers of prognostication. Yay, word. Because you're Cassandra, and Cassandra can build a Gantt chart like this that predicts exactly what is going to happen to everybody, including holidays and acts of death, acts of God, and death and bankruptcy and taxes, and the whole thing, all in a Microsoft project file. And so, yeah, there's this enormous disconnect when you try and do waterfall between what project managers think is going to happen and what actually happens when you get a bunch of programmers and sit them at computers. And so, yes. And so what this led to was in the 80s, some of the best programmers, some of the best engineers who have ever engineered got together on a project and they went, just tell us what you want, a little bit at a time, we'll build it, we'll deliver it back to you a little bit at a time, and then you tell us the next thing you want. And this is going to work, and we'll call this extreme programming. And they invented Agile. And Agile is brilliant if you have 12 of the best engineers in the world in an office together building software. If you don't have that, then you have to adapt Agile into a more structured and organized framework. And if you do that, what you end up with is King Scrum. And Scrum is to Agile as Burger King is to restaurants. It's in the same vicinity. It's kind of like adjacent, but it's not. It's not Agile at all. Scrum, you can tell Scrum's not Agile by the fact that if you've got 8 people working together on a team, then you are losing at least 8, probably more likely 16 man days out of every 2 weeks because of sprint planning, backlog grooming, sprint retrospective, sprint review, sprint presentation, seriously, we have 2-week sprints. We spend at least 2 days out of all of those, not to mention the 15-minute stand-up in the morning that now we're all doing it sitting down on Teams, takes 45 minutes. So that's another man day that's gone out of every iteration. You're now down to 7 days to actually build and ship some software. So no, don't do Scrum. If anybody tries to make you do Scrum, tell me where they live and we'll fix it. There's actually what I like in this kind of thing is Kanban. So if you have discipline, and you don't need to be the best engineers in the world, okay? It's not that level of just get on with it. But it is. I use Kanban for my individual projects. I've literally got a board, and it's got post-it notes and pins on it, and I kind of just go, oh, what can I be bothered to do today? I'm going to do that one, and I just move it across, and I have a to-do and a doing and a done, and then it goes off. And obviously, if you're in a team and stuff, then you've got right to do, and then doing, and then code review, and then testing, and then done. And done means this is actually now running in production. But Kanban simplifies all of this kind of stuff. You have your backlog. You kind of go, well, if things are more important, let's move them to the top of the column. And if they're deprioritized, we'll move them back down again. And then you move stuff across. Kanban is the thing that lean manufacturing in Japan was doing, the whole Toyota thing and Mary Poppendieck and whatever, that whole lean approach. They were using Kanban. People needed another box of steering wheels, they would go and find the box of steering wheels card and they put it up there. And then the next time the people who made steering wheels came along, they go, oh, people need steering wheels, I'll do that. That's how that works. And you can have a meeting every now and then to go, hey, everybody, how's Kanban working for you? And they'll go, yes, fine. And so that saves you 2 days out of every 2 weeks where you don't need people. And then you have something like Spot, so that if somebody's being a problem on the team, you can just grass them up anonymously. I was reading a sign in your toilet. But yes, you have Teams, you have Slack, you have Discord in some cases. Have you ever worked at a company that uses Discord? It's so weird, especially because the way that you're logged into all the servers at the same time, and so you've kind of got the that's work, and that's the Disney Speedstorm where people are complaining about the in-app purchases. But yes, Kanban basically boils everything in your entire project plan down to, this is what I'm doing now, that's what I'm probably doing next, there's some other stuff that's going to happen later, I'll worry about that when I get there because I can't even see it properly yet. Okay, this idea that you're going to do these things in this sprint and give it a theme and the name of The Boys episode or something. If you have to start being cute with the naming of things in order to make it tolerable, then maybe just stop doing the things. Okay, so there you go. It's all been very ranty, and I would just like to summarize before I let you get back to your lives. So, in summary, do the minimum possible, the absolute minimum possible to come up with a functioning solution that does the things you want it to do. Use ASP.NET Core MVC or Razor Pages. Server-side rendering is fine. Little bit of JavaScript to make it interactive where you need it. Use text files. If you can't use text files, use a SQL database. If you can't use a SQL database, do something else. Use RabbitMQ. And then if you decide you want to go to a bigger library thing somewhere, you can switch to Service Bus or one of the hosted RabbitMQ options. Use Redis for caching stuff. It's all very, very simple. But you're going to need to use the simplest solution for any given problem space. We're going to use SQLite and MVC and container apps and plain JavaScript. You are only going to add complexity to these situations, these projects, these solutions, only when it is absolutely necessary, only when you have identified an actual problem with the solution or with the requirements or something where you go, that's not going to cut it just with SQL Server or just with container apps. We're going to have to actually bring in something a little bit more complicated. If you want to add that complexity, you need to justify it in a design review, so that when somebody says, when I come and do my very, very expensive consulting, where I come down and real world example, get parachuted into a team that has been trying to ship something for 18 months, find out that despite the fact they're only responsible for one microservice, they've got 17 Git repos, 3 of which are NuGet packages that are shared by all the others. So you have to build the NuGet packages, then you have to rebuild all the other repos. And I collapsed this whole thing down to 1 repo, 2 Visual Studio solutions, and they shipped 4 weeks later. So yeah, And yeah, so you have architecture design reviews. If you want to add in Cosmos DB, then you say, I have done an analysis of the options. Here is Cosmos DB, here is a text file, here is SQL Server, and here are the reasons why each of them is good and not good. And I have chosen Cosmos DB as the necessary solution. And you can then keep that as part of your artifacts for your project. And then when somebody comes along and goes, oh, why did you use Cosmos DB? Mark says you shouldn't do that. You go, yeah, but he did say we could use it if we needed it. Okay. And I know what you're thinking. You're thinking, but I want to put Cosmos DB on my CV. I want to put React and Redux on my CV so that I can go and get a better paid job. So in this shiny new agency over here, I want to know how Kubernetes works. I want to have that on my CV. So I'm putting on my kind of like old man thing here because I am an old man and I have been doing this for 35 years. Yeah, professionally. And so I'm going to tell you, it's okay to lie on your CV. All right, don't go over the top, but absolutely, if you know JavaScript, then say, oh yeah, I know React and Angular and Vue and Svelte and Ember and whatever Astro.js and Next and Nuxt and stuff. Because if you apply for a job that they want that for, and then they go, oh, can you come in for an interview next week? And you go, oh, yes. Which particular things will you be asking about? And they will go, oh, we'll be asking you about React and Redux. It's the fundamental idea of it is simple enough that you can learn that in an evening. Okay, React and Redux are really not that complicated in terms of the concept. It's just when you try and do things with them, they become really complicated. So yes, you know, don't claim to be an expert on medieval German architecture, because that sounds like a whole degree course. But if you want a specific technology on your CV, just put it on there. And then if anybody actually asks about it, I mean, I've got C# on my CV. I'm probably one of the sort of most experienced C# programmers in the world, because I've been doing it solidly for 24 years now, which is as long as it's existed. But I cannot get through a day of writing C# without visiting the docs, because, you know, knowing stuff these days in computing is not about knowing stuff. It's not about the stack of 4 ring binder manuals. It's about knowing how to Google. It's about knowing where to look when you need to find information on something. And it's about knowing how to read documentation and navigate it. And that is the skill that we have as developers and engineers. So when it comes down to actual specific technologies, just put them on your CV, worry about it later. So, do we have any questions? Hello.
Lots of people are reading, lots of people saying that you need a beer.
I need to get yes, I need to drive home and then I have something better than beer. But thank you. Sorry, I think we did have a question. I'll stand here so you guys can hear me.
Firstly, I'm going to say, yeah, I also agree with a lot of what you're saying. So if anything sounds confrontational, it's because I agree with you.
Okay.
You went into great depth going and saying, are people putting Node onto their servers because they want to have like a dev experience and basically crapping all over dev experience? But then you went and said, oh, and I run Kubernetes on my Raspberry Pi because I want the dev experience. You didn't say I want the dev experience, but you then said, I don't even need to know where it is because of this webhook and this thing, which gives you the dev experience.
Technically, that's the ops experience.
Yeah.
I never said anything about the ops experience. No, I completely appreciate that. It's not compromising anything. Running it in Kubernetes on that Raspberry Pi isn't compromising anything. It's not increasing the size of the download. It's not slowing anything down. The point where I get cross with the developer experience is where it's negatively impacting the end user experience or the customer experience, because developers don't know how to build an application with anything except React and Redux, or with anything except Angular. And so everybody just has to put up with downloading 5 megabytes of JavaScript before they can do anything. So yes, on the back end, I accept your point, but actually it would have been more complicated to do the auto update running it as a service under systemd, and sort of pulling multiple files down and extracting them somewhere on the disk and all this sort of stuff. Whereas you get a container, you yank it, you run it, and and also it is a single node, so it's not a Kubernetes cluster, and Kubernetes clusters are where Kubernetes really starts to go wrong.
This was mainly because of your pipe to Cloudflare being a Kubernetes
Yes.
container rather than just being a regular Docker container.
Yeah, so Cloudflare publish a Cloudflare container image that you can actually set up as the load balancer on a Kubernetes instance. And so I have a couple of other services running on that same thing. And Cloudflare just receives all the incoming connections and then pipes them off to wherever they need to go. Yeah. Absolutely, yes. Yeah. Yeah, it was the Cloudflare tunnel that pushed me in that direction. Yeah. Yeah. It is. So yeah.
So I went from working with a client who invested effectively a huge amount of money. They needed to break up a monolith into a modular monolith.
Yep.
But not modular monolith, a distributed monolith.
A distributed. Oh yes.
So
okay.
It's a microservice / service oriented architecture in name only. They're not stupid. They couldn't run it as long as anymore because it costs too many servers.
Yes. Yep. That's fine.
Incredibly big business, incredibly high performance, massive code base of mess. Firstly, no amount of goodwill in the world will ever make millions and millions and millions of lines of 20 years of continuous improvement on code make it clean.
Yeah.
So they went and broke it up into a distributed model. But they invested a huge amount of time in retraining all their staff into Golang, so that they can say, right, we're going to build this high concurrency, high performance system. Then I went to work with a different client who had also built doesn't really have performance, but also built a microservice, and they built it in Node.js.
Yep.
And I was like, why did you use Node.js instead of a proper language for it? And the answer, and I've had this from another team who used Python instead of Scala, was, do you know how much it costs to hire a developer with the correct skill set? JavaScript developers are cheap.
Yes.
Or Python developers are cheap.
Yes. So there you go. Don't do Node or Python. Do Go. We get paid more.
And then you can find a job doing something you like. They won't be in the same.
No. Yeah, and I mean, there is a thing in there. If you're building a site and you're expecting kind of at peak operation to be getting like 1,000 requests a second, then yeah, okay, Node.js is probably fine. I mean, anything else would be better, but Node.js is, except maybe Ruby. But yeah, the idea of retraining everybody, I've seen similar things except with Rust, and the churn when you've got a bunch of engineers who have been happily doing Node and React and Express.js and all that sort of stuff, and you say to all of them, hey, learn Rust, and you will lose about 80% of them because they will just hate it and feel like the compiler is personally attacking them, which it is. But yeah, again, and I think this is a theme of this, which I could probably emphasize more, but it's don't do stuff that you don't need to do, I think is probably another way of summing this up. And so if you don't need to retrain all your staff in Go, then don't. And yeah, the flip side of that is the faster and more efficient and more performant you can make your code, the less resources it needs to run, and the smaller the carbon footprint it has, which the people of Wales will be very grateful for. Because it might make it stop raining, or at least make it stop it getting any worse. But yes, also Go's weird. Do you know how Go does date formatting? Yeah. If you don't know how Go does date formatting, it's got a magic date, and you write that date, and it's like it's January the 2nd, 2003, 4:05 Mountain Time, which is 6 or 7. Anyway, there's a very weird way you can put it where it's 1, 2, 3, 4, 5, 6, 7. And yeah, passing dates or formatting dates, you don't use YYYY like everything else in the world. No, you use this one date that Rob Pike came up with. Everything else in there, though, is actually pretty good. I like Go. Every fucking time.
I didn't think it's something like a day of the month after the 12th, which means you can sort them around and not realise you're American.
But no, Go made it into my worst programming language ever taught, just on the strength of its date formatting. So yeah. It is. Oh yeah, Go routines are amazing. And it is a very, very easy language to learn, actually, because it really doesn't do very much. The syntax is not complicated. Not a fan of the error handling, but that's because I'm lazy. Okay. All right. That's it. I'll hand you back over to Pete. He can tell you what's happening whenever. Thank you. My speakers are already muted.
That's okay.
Yeah.
Good. Thank you very much for coming along, folks. Thanks to John Staveley and Rendell for the 2 awesome talks. I'll give them another round of applause.